Welcome to this class. Today I am continuing the chapter electricity. We have divided electricity chapter into 6 different parts, and this is part 4. And in this part we are going to focus on laws of resistance and series combination of resistance. And this is of the subject Science and Technology of class 9. Okay, look at this, laws of resistance and series combination of resistance. We are going to focus on this, but before this, at least we must have clear idea about the resistance, and then only we will be able to understand these laws, and then resistor, what is it, and then we will be able to understand series combination of resistor. That's why I want to start with electrical resistance, what it is. Look at this, electrical resistance, the obstruction offered against the flow of current by a conductor is called its electrical resistance, and it is measured in ohm. What it means? Obstruction offered. If current is made to flow through copper wire, aluminum wire and silver wire, the flow of electron or flow of current will be very easy. The obstruction is negligible. That's why they have negligible resistance. And if they have negligible resistance, then they can be used to conduct electricity from one place to another place. But silver is expensive. That's why silver is not used to conduct electricity from one place to another place. Aluminum is used to conduct electricity from powerhouse to our houses also. And copper wire is used inside the house because its ductility is very high, and that's why these are the metals which we use to conduct electricity, because the obstruction against the flow of current is very less, negligible. They have negligible resistance. But there are some other metals, they have more resistance. Iron has more resistance than copper and aluminum. And in the same way, nichrome, this is an alloy of nickel and chromium, it has very high resistance and it obstructs the flow of current a lot, and that's why it becomes red hot. In the same way, tungsten has very high obstruction against the flow of current. Different metals have different obstruction against the flow of current, and that's why they have different resistance. And this resistance is measured in ohm. The SI unit of resistance is ohm, and in the name of the scientist ohm, the unit of resistance is taken as ohm. We can understand this resistance with the help of short video clip like this. This is, let's say, a conductor wire. I have magnified this conductor wire to make you very clear, and it is full of atoms. Millions of atoms are packed in this conductor, and flow of current means flow of electrons. When electron flows through this conductor, certainly it flows by colliding with the atoms of the conductor. And if this collision, number of collision is more, then obstruction is more, and number of collision is if less, obstruction is less. The obstruction depends upon the number of free electrons contained in this metal. Okay, now let's talk about this resistor also. What is resistor? Resistor actually is the conductor having high resistance, or the substance having high resistance is resistor. It is used intentionally in the circuit to convert electrical energy into other form of energy. Sometimes we use it to convert electrical energy into heat energy in the circuit. Sometimes we use it to convert electrical energy into light energy, sometimes mechanical energy, etc. Actually, resistor is conductor which has high resistance, and it is designed in the circuit to produce certain resistance to convert electrical energy into another form of energy. Now we can define this way. Resistor is an element of the circuit that is designed to produce certain resistance in the circuit. It has high resistance. Okay, resistor can be represented by this symbol in the electric circuit. A symbol is straight line and ups and down. The line is moving up and down, zigzag lines, and this is the representation of the resistor in the electric circuit. In electric circuit, if you have seen this, it means this is resistor wire and its resistance is high. Now I want to give you some example of resistor. There are some common resistor which are used in laboratory also in different purpose. Nichrome, another is constantan, another one manganese, another tungsten. These are very common resistors which we use in the electric circuit. Now let's talk a little detail. What is nichrome? It looks like this. It is silvery white, and this is an alloy of nickel and chromium. You have seen this. This is used in electric heater. The coil of electric heater is made up of nichrome. When current passes through it, its high resistance makes it red hot. Because of the very high resistance, it obstructs the flow of current to very high amount, and it becomes red hot and converts electrical energy into heat energy. This is used in all the heating instruments. Another example, constantan. Actually, this constantan is an alloy of copper and nickel, and this is also used as resistor in electric circuit. And manganese, it appears like copper, but this is an alloy of copper, manganese and nickel. Alloy means mixture of metals. Mixture of metal is called alloy. But this one, this is not the mixture of metal. This is single element tungsten. It is used in the bulbs. The filament of the bulb is made up of tungsten. When current passes through it, because of huge resistance, it obstructs the flow of current a lot, and it becomes white hot. Not only red hot, white hot. When a metal becomes white hot, then it converts electrical energy into light energy also. That's why it is used to convert electrical energy into light energy in electric bulbs. Okay, after this example of resistor, now I want to tell something more about the resistance. Can we expect that nichrome, tungsten, manganese, constantan all have equal resistance? Does it depend upon length? Does it depend upon thickness? What factor affects the resistance? All of them have same resistance? No. Different substances have different resistance. In the same substance also, if length is changed, thickness is changed, temperature is changed, its resistance also changes. Then what are the factors on which resistance depends? This is the question. Now I want to tell you the factor. Number one, resistance depends upon length of the resistor, and it also depends upon thickness of the resistor. Thickness means cross-section area. If a conductor is cut down, and if we see from the thickness, this is the cross-section area. And it also depends upon temperature of the resistor. It depends upon nature of resistor. Now we can say in one sentence also, if you are told that on which factor resistance depends, then you can answer like this: resistance depends upon length, thickness, temperature and nature of resistor. But these four factors are taken as law. I mean to say, law of resistance is made according to these factors. Now I want to enter into laws of resistance. What are the laws of resistance? Number one, resistance is directly proportional to the length of the resistor. Mathematically, R is directly proportional to L. What it mean? If length of the resistor is more, its resistance will be high. If length is less, its resistance will be less. If we have a nichrome wire of 10 centimeter length, its resistance will be less than that of the 20 centimeter long nichrome wire. Resistance increases with the length of the resistor. Now next, resistance is inversely proportional to cross-section area of the resistor. Mathematically, R is inversely proportional to A. What it mean? It means if resistor is thick, resistance becomes less. If it is thin, resistance will be more. Thicker the resistor, less will be the resistance. And this is the meaning of inversely proportional. If thickness increases, resistance decreases. Now next, resistance is directly proportional to the temperature of the resistor. What it means? If we use 10 centimeter long nichrome wire of 10 degrees Celsius temperature in the circuit, its resistance will be less in comparison with the 10 centimeter long nichrome wire of 40 degrees Celsius temperature. If temperature of the same resistor is more, then resistance will also be more, and if temperature of the same resistor is less, then resistance will be less. That's why resistance is directly proportional to temperature of the resistor. Now another one, resistance depends upon nature of substance. What it means? If we have same length, same thickness, same temperature, one is nichrome wire, another is copper wire, then naturally nichrome has high resistance than that of the copper. Copper has negligible resistance, nichrome has very high resistance. Actually this depends upon the structure of the atom. How many electrons are there and how are they arranged, and how many free electrons are present in nichrome in comparison with copper. If free electrons are more, I told you about free electrons in previous class, if free electrons are more, then the resistance will be less. Okay, these are 4 laws of electrical resistance. Now I want to talk about these again in detail. Why resistance depends upon length of the resistor? If you are questioned, resistance is directly proportional to the length of the resistor. Why? If this is the question, we can answer this way. Let's say this is a conductor wire and current is flowing, electrons are flowing, and the obstruction will be offered by this conductor wire up to this much length. If the same current is passed through another conductor wire of the same material, same thickness, but length is long, then the obstruction against the flow of current will be up to long distance. Since obstruction is offered up to long distance, that's why the resistance of long resistor is more than the resistance of short resistor. Okay, this can be proved experimentally also. I want to describe one experiment in which we can prove that when length increases, then resistance also increases. Resistance is directly proportional to length. I want to show this experiment. Look at this. Resistance is directly proportional to the length of the resistor. We are going to prove experimentally. Let's say this is the symbol of battery and it is connected to a ball. Here it is, but the circuit is open. Two ends of the conductor is open. If we connect metal clip at two ends of the conductor, till now the circuit is open. Until and unless we connect this to metal clip, current does not flow and the ball won't give light. Okay, if we connect this metal clip, I mean to say if a resistor of short length is taken and its two ends are clipped by this metal clip like this, it is short resistor, then current flows from positive to negative terminal, and because of this reason bulb gives light. Okay, in the same way, if we manage the same circuit and if we clip a long wire, I mean to say long resistor, 2 ends of the long resistor is if clipped, then again current flows from positive to negative terminal. Now bulb gives light. Now we are going to observe the brightness of the bulb. Exactly what happens if this is 12 volt battery, then what can we expect? It supplies 12 joule energy per coulomb charge when 1 coulomb charge makes 1 round of this circuit. And the same 12 joule per coulomb charge will be divided between these two, resistor and bulb. If resistance is high, then it will get high amount of energy per coulomb charge, and this bulb will get less amount of energy per coulomb charge, and the bulb becomes dim. But if the resistance is less, then what happens? It gets less amount of energy per coulomb charge. Then the bulb get high amount of energy per coulomb charge and brightness of the bulb will be more. In short, what can we say? If resistance is high, the glow of bulb will be dim. If resistance is less, glow of bulb will be bright. Now what is observed? This, when short resistor is connected, then the glow of bulb is found to be bright. But when long resistor is connected, then bulb is found to be dim. This way we can decide that resistance increases with the increase of the length of the resistor. Okay. Now let's talk about the second one. Resistance is inversely proportional to the cross-section area of the resistor. Why? Now I want to tell you with the help of this diagram. This is a conductor. If we take a cross-section area like this cross-section area is very less. And this is another conductor which is thicker than the previous. If we take cross-section area, the cross-section area will be wider. Look at this more. Now what happens? Thin wire provides narrow path for the flow of current, but thick wire provides wide path for the flow of current. That's why flow of current becomes easier in thick wire than that of the thin wire. So we can say that resistance is inversely proportional to cross-section area. Now it can be proved with the same experiment. Look at this. Let's say this is a battery connected to a bulb and there's metal clip, and if we connect this two end of the metal clip by thin wire, and another case if we connect the same with thick wire, then what is the difference between these two? I mean to say the glow of bulb, how differs? I mean to say when thin wire is used, then brightness of the bulb is found to be less, it becomes dim. And when thick wire is used, the brightness of the bulb is found to be more, so it glows brightly. It means thick wire has less resistance, that's why bulb is being bright, and thin wire has more resistance, and that's why bulb is dim. Resistance is inversely proportional to the cross-section area of the resistor is experimentally proved. Okay, next. Resistance is directly proportional to the temperature of the resistor. What it mean? We can take one short video clip. Look at this. In this video, what is shown? This is the conductor wire and its molecule is vibrating. And when its temperature increases, then rate of vibration of the molecule increases. High temperature means the same molecule vibrates vigorously. And if electrons are flowing through this conductor and the rate of vibration of the molecule is high, temperature is more, then number of collision with the atoms will be more. I mean to say the electron collide with the atoms many more times when it is hot. That's why the hot wire produces high resistance than that of the cold wire. It can be experimentally proved this way also. The same experiment we are doing, if this is a cold wire connected and glow of bulb is observed, and if this is the same is heated and hot wire is connected, then the glow of bulb is observed. Then what is found? When cold wire is connected, then glow of bulb is bright. What it means? Its resistance is less. And when hot wire, the same is if heated to high temperature and connected, then bulb is found to be dim. It means hot wire has high resistance, cold wire has less resistance. Resistance is directly proportional to temperature. Okay. Now next, resistance depends upon nature of substance. If this is nichrome wire and another wire is taken which is of same length, same thickness, same temperature, copper wire. If current is made to flow through these two wires, what is found? Nichrome wire becomes red hot, but copper wire, its temperature rises a little only. What it mean? Nichrome has very high resistance, it obstructs the flow of current a lot. That's why we can say that the resistance depends upon nature of the substance, how the electrons are arranged in its atom and how many free electrons they contain. If free electrons are less, then resistance will be high. In case of nichrome, free electrons are very less in comparison with copper. That's why resistance of nichrome is very high. But resistance of copper is negligible because number of free electrons are very huge in copper. That's why resistance depends upon nature of substance. All other physical conditions are same. Even after this, a substance has high resistance, another substance has less resistance. Okay, we can prove this with the help of the same circuit. The circuit is if completed by using copper, and another circuit is same circuit is completed by using nichrome. Now, if we observe the glow of bulb, then what is found? When this copper is used, the glow of bulb is bright. When nichrome is used, it becomes dim. What it mean? Copper wire has very less resistance, that's why bulb is bright. It has very high resistance, that's why bulb is dim. This way, I finish this laws of resistance also. I told you what is resistance and what is resistor, and we did laws of resistance also, and we can prove now the laws of resistance experimentally also. Now let's take a break with question. I want to present one question. Look at this. At first a thin and then short and lastly a cold resistor is if connected in the given circuit respectively, and the brightness of the bulb is observed, then which of the following result will be obtained? Now there are some options. First the bulb glows dim and then bright, and lastly again dim. First the bulb glows bright, dim, bright is written here. But if we go through these options, then we'll be confused. We have to go through question and this diagram. The question is, first this resistor used is thin. I mean to say thin resistor is used first and glow of bulb is observed. Secondly, short resistor is used and glow of bulb is observed. And lastly, the cold resistor is used and the glow of bulb is observed. Now, what will be the result among these four options? Now, when thin is used, then certainly the glow of bulb will be dim because thin wire has high resistance, thick has less resistance, and thin is used, high resistance. That's why the glow of bulb will be dim. Now remember, first dim, and short is used. If short wire is used, short wire has less resistance. Secondly, short wire is used, it has less resistance. If less resistance, then bulb will be brighter than the previous. When thin is used, dim. When short is used, then bright. Lastly, cold resistor is if used. Cold has less resistance, but hot has high resistance. If less resistance, then again the bulb glows brighter. Thin, dim, short, bright, and cold also bright. Dim, bright, bright. We have to select one of the option. Where is it? Dim, bright, bright. First the bulb glows dim, okay, bright, and lastly dim. No, this option is dropped. First the bulb glows bright. No, first the bulb glows dim, okay, and then bright, and lastly again bright. Yes, this option is the correct option among four, I think. Now let's take four also. First the bulb glows bright. This is wrong. That's why third option is correct. We'll tick on third option. Okay, now resistor and resistance we finished. Now I want to enter into combination of resistor. Let's start combination of resistor. Resistor can be combined with each other, and two or more than two resistor can be used together. You have noticed that in your house also there are many appliances. How are they connected? They may be connected one after another in series, or they may be connected differently in parallel. And all the appliances have certain resistance. That's why we can say that the connection of appliance can be considered to be the combination of resistor, or combination of appliance is also the combination of resistor because they have resistance inside the appliances. Okay, resistors can be connected in series or it can be connected in parallel. There are two types of combination of resistor. Now, today we are doing the series combination of resistor, and in another class we'll do both of them and we'll compare them. What is series combination of resistor? We can define this way. When resistors are connected end to end with each other and the open end of the first and last resistor is connected to the source of electricity, then the combination of resistor is called series combination of resistor. Very long definition, seems to be a little confusing. I want to make you very clear with the help of animated diagram, the same definition. Look at this. This is a resistor. If its one end is connected to another resistor and its one end is connected to third resistor, and we have now two open end. The open end of first and open end of last is if connected to a source. Then this type of connection is called series combination of resistor. These resistors are connected in series. Now I want to show this with the help of diagram, and I want to describe the characteristic of series combination of resistor. Look at this. This is a battery. If we connect resistor end to end like this, now this is the resistance of this resistor is, let's say, R1. The resistance of this is, let's say, R2. Resistance of this is, let's say, R3. Because they may have different length, different thickness, that's why resistance will be different. And what do you think? Current flows from positive to negative terminal, isn't it? This is conventional current. And if current is denoted by I, we always denote current by the symbol I. Then what do you think? The current which flows through R1 is equal to current which flows through R2 and R3 or not? Yes, certainly. There is only one path for the flow of current. That's why what amount of current passes through R1, the same current passes through R2 also and R3 also. If it is 1 ampere, then 1 ampere current passes through each of them. If it is 2 ampere, 2 ampere current passes through each of them. It's very simple and clear. Now, if we measure potential difference between positive and negative terminal of this battery, neglecting the internal resistance, let's say if it is 12 volt, this is 12 volt battery, let's say, and supplying 12 joule electrical energy per coulomb charge, then this PD across this R1, I mean to say PD, do you remember what is PD? This was taught in previous class. Energy conversion between 2 points of a circuit by the flow of 1 unit charge is called potential difference between those 2 points. That's why potential difference between these 2 points per coulomb charge is the PD across this resistance. And potential difference between these 2 points per coulomb charge, how much electrical energy converts to heat energy between these 2 points when 1 coulomb charge crosses this cross section is PD across R2. Let's say PD across R1 is V1, PD across R2 is V2, and PD across R3 is V3. Then if we measure potential difference, total potential difference between this positive and negative terminal, and it is if 12 volt, the same 12 volt is found to be dividing among these 3 resistors. That's why in this circuit, first characteristic, what can we say? Same current passes through each of the resistor. Current remains same. Same current. If it is 1 ampere, 1 ampere for each. And second point, the total potential difference that can be represented by V is found to be equal with the sum of the potential difference across each resistor. Practically we can do this. I mean to say, if it is 12 volt, then here maybe 6 volt, here it may be 2 volt, 6 plus 2 becomes 8, 8 plus 4 becomes 12, or maybe 4 volt, 4 volt, 4 volt. Potential difference total is equal to sum of the potential difference across each resistor. Now we know Ohm's law also, it was taught in previous class, V equal to IR, and for this first resistor same Ohm's law gives another symbol, V1 is equal to IR1, because PD across first resistor is if V1, current in this resistor is I, and resistance of this resistor is R1. In the same way, V2 equal to IR2, because current is same but resistance is R2, and V3 is equal to IR3. And if we substitute this here, in place of V, I am writing IR, and in place of V1, IR1, V2, IR2, and V3, IR3. We can take I as common here, R1 plus R2 plus R3, and if I is cut, then we'll get what? R equal to R1 plus R2 plus R3. If there are other resistors, that can be R4, R5 also. What is the conclusion? This is third conclusion. In this combination, in the series combination of resistor, total resistance is equal to sum of the resistance of each resistor. This conclusion can be written this way. Look at this screen. What are the characteristics of series combination of resistor? First, same current flows through each of the resistor. Now second, total potential difference is equal to sum of the potential difference of each resistor, which can be mathematically represented by V equal to V1 plus V2 plus V3 plus ... And third conclusion, total resistance is equal to the sum of the resistance of each resistor, R equal to R1 plus R2 plus R3 plus ... When resistors are connected in series, what will be the effect on current? What will be the effect on potential difference? What will be the effect on resistance is described here. These are the characteristics of series combination of resistor. Now I think series combination is clear. I want to present one numerical problem also. Look at this. You are told to connect 3 resistors of resistance 10 ohm, 15 ohm, again 15 ohm in series respectively, and connect it to a 12 volt battery. Neglecting the internal resistance of the battery, calculate the following. What? Number 1, total resistance in the circuit. Number 2, current in the circuit. And number 3, potential difference across each resistor. Now I'm going to solve this numerical problem. First we have to write the given information. It would be better to have a circuit, electric circuit. Electric circuit is not asked in the question, but if we make electric circuit, we'll be comfortable to solve the numerical problem. Okay, let's do this. This is the battery, and this is connected to 3 resistors. One is of 10 ohm, another is of 15 ohm, and third one is of again 15 ohm. This way, this is R1, R1 is equal to 10 ohm. Let's say this is R2 equal to 15 ohm, and this is R3, and this is equal to again 15 ohm. And 12 volt battery, if internal resistance is neglected, then what is the question? Total resistance in the circuit. Total resistance, number 1, resistance is equal to question mark. How can we get this? We have total resistance is equal to sum of the resistance of each resistor in series combination. That's why this is equal to what? 10 ohm plus 15 ohm plus 15 ohm, and this is equal to 40 ohm. This is total resistance. And what is question number 2? Current in the circuit. Now to get the current, I equal to question mark. How to calculate this? We have V equal to IR. In this equation, I equal to V by R. Okay, now I want to write here. I equal to V by R. V is 12 volt. R is 40 ohm. That's why we can write I equal to 12 volt upon resistance 40 ohm. Now 4 3s are 12 and 4 1s are 4, 0. This is equal to 0.3 and unit of current is ampere. The current is 0.3 ampere. Now second part is also finished. Now third part, potential difference across each resistor. Potential difference across first resistor is V1, second resistor is V2 and third resistor is V3. That's why in question number 3 we are going to find out V1 is equal to V equal to IR. That's why I is same, IR1, this is equal to I is 0.3 into, I am not writing unit, R1 is 10, this is equal to 3 volt. Now what is V2? V2 is equal to IR2, this is equal to I is 0.3, R2 is 15, this is equal to 15, 3s are 45, 4.5 volt. Now V3, what is V3? IR3 and this is equal to 0.3 into again the same 15 ohm, this is equal to 4.5 volt. Okay, this way we can calculate B1, B2, B3. Now I think I finished. Today what we did, first what is resistance, what is resistor, and then laws of resistance, and the reason also I told, and I proved these laws with the help of experiment, and this experiment I explained, and after that series combination of resistor, its characteristic, and you are now able to solve the numerical problem also. I think this is clear to you. Now time is finished. We will meet in next class. Thank you.